everybody. Welcome to class today, October 24th. Thanks for watching the video. As promised, you have a welcome screen just like normal. We are going to grade assignment 35. Check what you're doing right now and make sure you've turned that in. I will be putting those grades in and grading as we go. And if you're turning yours in after the answer key has been up in this video, going to be late grade. Do not skip the video. Okay, we talked about this in class yesterday. It's a very important skill at the end of the notes. You'll be submitting your notes with your assignment. We talked about that yesterday too. If you would happen to finish the video today and the assignment, then you can be working on your IXLs that will be due on Friday. Really quick, I explained this yesterday in class, but if you were one of the people who need to make up the quiz from before fall break, and there are about 6 or 7 of you, you need to make sure that you come up to the teacher and let her know that you need that. There are your name and your period number on the quiz next to the subplans. I've explained it in the subplans for the sub as well. Leave your phone and move your desk away from others, and then take the quiz and then start the notes. Everybody else should be working quietly, nothing out on your desk, not talking to them, and be focused so that it is a quiz environment, even though we're not in rows like a normal day. All right, let's get started. Key to 35. And again, hopefully this isn't a lot of checking because you had the answers there to help you. I'm going to go through this really quick on the video. You need to stop your video so you can see the answers, and then replay it when you're done. Please make sure you are looking for the work. I did all of these following the guidance we did yesterday, trying to keep the variables positive when possible. But that's where we would be. Pay special attention to the 2 word problems. Writing what we're looking for there, finding the number, setting up exactly what those words say. And both of these you would start with N is a number. And then 3 more than 5 times a number, that's this half, is the same as 30 more than twice the number. Solving from there. I don't think I put the puzzle key in here, but I can't remember. I don't have the worksheet in front of me. Something about crooked B's, and I'm not sure. We'll talk about that in class when I get back on Wednesday. I know lots of you don't take time to do the puzzle, but it was kind of cute and funny. At this time, you should have the notes that needed to be handed out to complement the notes video that I'm about to show. So if you did not get a copy of those from the sub, they are up in the sub plans. Ask her to please give you those. My instructions were for her to give those to you while you were working on your bell work or grading assignment 35. Make sure 35 is in your binder for binder check. And then today's notes you'll be handing out now. Date and title needed, and completion of all the examples needs to be there for the assignment portion. Today is October 24th. Okay, at the top of your page, we are going to involve the distributive property. And this portion is not written on your notes. If you need a refresher, the distributive property we have talked about this year, but in case you have forgotten, the distributive property is the product of a number, and a sum is equal to the sum of the individual products and the add-ins. Basically, it's the pass-out item. We've worked on this property before break when we were simplifying expressions. Here's what it looks like algebraically. A times B is the same as, or A times the quantity B plus C is the same as A times B plus A times C. And so whenever we have distributive property involved in our multi-step equations with variables on both sides, you've got to distribute and then move. Just like yesterday we talked about collecting. Okay, before you move, you have to distribute before you move as well. So in the steps of order, we'll be doing distribute, collect, and then move. And so putting together all the things we've been doing before break and solving and just kind of making those equations be more and more challenging. Take a minute right now and see if you can do the 2 review examples. So examples 1 and 2 are review. Those are all things we've done already together, nothing new in either one of those. Number 1 is before break, and number 2 is reviewing what we did in class on Monday. And then what we're going to do is put those 2 topics together into one equation for today's new notes. So pause the video, do problems 1 and 2, and then start the video when you are ready. Okay, so distribute first. I know some of us were talking about, do we have to distribute? You would not have to distribute in number 1. You could divide by 7, but several of the problems we're going to be doing today will require that. So just for the practice, I'm sure you have 7x minus 21 equals negative 49. Then you are going to add 21 to both sides. Really work to be neat in showing those steps so you're not losing things in translation. 41 down and 21 up is going to be negative 28. Divide both sides by 7 and you get x equals negative 4. That was questions that were on the quiz. Hopefully we are all good there. If I had divided by 7 first, I would have gotten x minus 3 equals negative 7, and I would have added 3 to both sides and got x equals negative 4. In example number 2, I am going to start by subtracting 3x based on our conversation from yesterday. That would keep my x's positive. So that would leave me with 3x plus 18 equals 28. And then here I have a 2-step equation that we should be feeling pretty good about. 28. Oh, Ms. Kearns wrote 28. That would be a problem. I was like, that's not going to work out very nice. It was 24. So my next layer would be 3x, and plus 18 minus 18 would leave. And then I've got 24 minus 18, which would give me 6. Dividing both sides by 3, x equals 2. Remember, you can always plug these in and check it. This would be 12 plus 18, which is 30. Plugging in here, I would get 6 plus 24, which is 30. Since these two things are the same, I know I've done those right. Okay. So what we're going to do today, still having equations with variables on both sides, like example 2, but now they're going to have some distribute involved in those. So let's look at a couple. Okay. Looking at problem 3. Again, I cannot start by dividing by 7. That would create an ugly equation because I would have 2x over 7. That doesn't help me. So I'm going to start with distributing. So you would have 2x equals 7x plus 35. And this brings us to the first problem where trying to keep my variable positive would actually make the problem more work. I can subtract 2x from both sides, but if I do that, then I get 0 over there, and lots of kids get confused, and then I've got to move the 35. So even though I normally like to keep my variable positive, if I just subtract 7x from both sides, that keeps my, that makes me have a 1-step equation. Does have a negative in it, not going to be able to avoid that. Negative 5x is 35. Divide both sides by negative 5, and x equals negative 7. Okay, so again, if you wanted to start with minus 2x, you would have had the equation 0 equals 5x plus 35, and then you would have had to move this 35 over here, and lots of kids freak out when they get 0 on one side. So yes, the rule of thumb is to try to keep the variables positive, but that's not always possible. Number 4, you got lots happening here. First thing we're going to do is distribute to get an equation that looks a lot like yesterday's. Monday's 5x plus 10 would be on the left, and 3x minus 12 would be on the right. From here, I would decide what move I want to do, and based on yesterday's conversation, I would be subtracting 3x from the right and the left, because minusing 3x over here will make that go away and leave me with 2x plus 10. Be very careful here. 2x plus 10 does not equal 12. 2x plus 10 equals negative 12. And I'm going to subtract 10 from both sides. 2x is negative 22. Divide both sides by 2, and x equals negative 11. Again, you can always plug those in. Negative 11 would give me negative 9 times 5, which would be negative 45. Negative 11 here would give me negative 15 times 3, which would be negative 45. So most definitely working there. All right, I'm gonna have you pause the video and move on to 5 and 6 and see if you can get those figured out. 6 is a little tricky. See if we got some big brains out there that can figure it out. So pause the video right now, restart when you have finished those, and then be ready to make corrections if need be. All right, for number 5, I hope you have 20 minus 5x equals negative 3x plus 4. Draw my wall here, and I am going to add 5x to both sides. And that would give me 20 equals 2x plus 4. Because a negative 3 and a positive 5. Then I'm going to subtract 4 from both sides. 16 equals 2x. Divide both sides by 2. X equals 8. Again, that plugs in, works out, all is well. Now we get to these problems involving fractions, and this is where kids freak out. So the first thing I want to tell you about fractions, if you've looked at the back side of your note, you'll see nothing but fractions. And we're going to talk about what to do, and there's a bunch of fractions. But if you have a fraction involved in a distribute, before you panic, you should see if the fraction will go away when you distribute. And so hopefully you notice that the fraction is 1/4, and 1/4 of 12 results in a whole number. So even though there's a fraction to start, not a big stressor. Let's work on distributing. Be careful distributing the negative. Negative 2x. And then you've got negative 2 and negative 5 is plus 10 equals 24. And 12 minus 1/4 x is going to be minus 3x. And that's the equation that you'll be solving. You've got to make sure you simplify it correctly in order to solve it. To do my first step in solving, I can either add 2x or add 3x. I'm in fact going to add 3x to both sides because adding 3x to both sides keeps my x's positive. This goes away. Here's my wall. 3x positive, 2x negative is going to leave me with x plus 10 equals 24. And I'm going to subtract 10 for a final answer of x equals 14. I feel like I've made an error there, and I can't figure out where it is. That would be 7, 9, 18. Just plugging it in here really quick on some scrap paper to make sure I have not made a mistake. It just looks weird to me because 1/4 of 14 is not a whole number, but that's okay. Let me check here and see. Yeah, that's okay. Does work out, even though you get a weird number. 14 is correct. Okay. All right, on to the back. On to the back, we're going to learn a very new tool that you've never done before, and it's a way to handle fractions. And so I'm not talking about fractions like number 6, where everything was nice when you distributed. I'm talking about fractions like the 3 examples you see on your paper, where there are fractions all over the problem. And one of the things we can do when we have fractions in the problem is we can do what we call clear those fractions. And to clear a fraction, you are simply going to multiply all terms, that's the key, by a common denominator. And so we are going to make every equation a bunch of times bigger. That's what multiplying does. And when you make it a bunch of times bigger, it makes the fraction clear. And so you don't have to do any work with fractions. You don't have to get common denominators. You don't have to do reciprocals. You don't have to do any of those things. And it's going to be really helpful as you get into more and more challenging problems, like the second example and the third example, okay? I get lots of kids here on this problem who think, oh, I'll just add 2/7 and get 6/7, and then I'll multiply by reciprocal. That all works, but we're gonna start with an easy one to try to show you how this tool works. Am I gonna make you learn this tool? I can't force you to use it. However, I can tell you on the test, if you clear the fractions on the problems involving fractions, you are way more likely to get it right than the people who try to just trudge through all the fraction work. Your brains just struggle with all of those steps, undoing all of those fraction steps, undoing adding and subtracting of fractions, undoing multiplying, dividing of fractions, all within an equation can be confusing. So we can look at this one, and I picked the first one to be very easy. What's the least common denominator of 4/7 and 2/7? 7. And notice how I put a set of parentheses around the whole thing. And what I'm going to do is I'm going to take this 7 times every term in the parentheses. So 7 times 4/7 would be the 7's canceling out and leave me with 4m. And then I'm going back to the original 7 and I'm taking it to the next term. And it's 7/1 times 18/1. So I'm literally taking 18 times 7. I'm making this entire equation 7 times bigger so that there are no more fractional parts. Oh, that's a 6. 56, so 126. So I'm going to have 4m equals 126, because that's 7 times bigger. And then I'm going back to the original 7 again, and I'm going to take it over here. And 2/7 times 7 is going to leave me with minus 2m. And now I've created a new equation that is equivalent. It's 7 times bigger than the first one, but it has no fractions, and I can follow the rules we just learned now. So how would I solve this? Well, I would add 2m to both sides, which would give me 6m equals 126. And I'm going to divide both sides by 6. M equals 21. And again, you don't have to clear fractions, but when you get to equations that look like this with a whole bunch of fractions in them, in this problem, you would have to get common denominators to add the 2/9 and the 2/3. Then you would have to clear that fraction by multiplying the reciprocal. You'd have to get common denominators between the 1/2 and the 2, and it just makes things a little overwhelming, okay? So instead, we can get rid of the fractions by figuring out what does 9, 2, and 3 all go into. And hopefully you're all sitting out there thinking about it and thinking, okay, 9 times 2, working it out, but 18 is what they all go into. So if I make 2/9 18 times bigger, that would be 18/1 times 2/9. That's a 1, that's a 2. So this first term would become 4n, because 2 times 2 is 4, and then 9's cancel out. Plus, then I'm taking 18 times 1/2. Now, I hope you can do that in your head, but 18 times 1/2 is going to be 9. I made the left side 18 times bigger. Pause the video and see if you can figure out how much the right side will be when I make it 18 times bigger. And again, it means you're taking 18 times the coefficient. So pause the video, write yours down, and then restart the video to see if you were on the right track. 3 is going to go in there once, and in there 6 times, so this is going to be 12n. And 18 times 2 is 36. And this new equation that I've created here that I'm highlighting in green is equivalent to the first equation, but it has no fractions in it, and life is nice. Now, when you get crazy fraction equations, sometimes you get crazy fraction answers, but a crazy fraction answer is way easier to deal with as just the answer than doing all the math with those. So I would start by subtracting 4n from both sides, leaving me with 9 equals 8n plus 36. And then I would subtract 36 from both sides, and 36 minus 9, or positive 9 and negative 36 is what we'd have. And that would leave me with negative 27. And this is one where it's like, uh-oh, it didn't work out. Well, again, we're going to start getting answers that don't work out, and that's okay. We would leave our answer as n equals negative 27/8. We're not going to make that a mixed number. We're going to leave it like this, and we're going to start getting answers that are not super pretty all of the time. Doesn't mean it's wrong if you step through there and see that. Okay. Last one. Before I start, think about the fact that I've got to work with a 5, a 10, and a 2 and decide what we're going to multiply every term by. Pause the video till you have that down. I hope you decided to multiply every term by 10. If I make 2/5 10 times bigger, 5 goes in there once and in there twice, that means I'm going to have 4n. If I take 10 times 1/10, that means I'm going to have plus 1. Now here's a tricky term. This is one term. So you're not going to take 10 times the half and 10 times the n and 10 times the 3, because this is all multiplied together. You're going to take 10 times all of this. So I would just take 10 times the half, which would give me 5n plus 3. And now I have an equation with no fractions. I'm going to distribute, like we talked about on the front. 4n plus 1 equals 5n plus 15. Following our guidelines from yesterday, I would subtract 4n. 1 equals n plus 15, and I would subtract 15 for a final answer of n equals negative 14. Now, on your assignment tonight, you are not going to have a bunch of problems that have all fractions in them. You're going to have some pretty basic, easy ones. But when you get to one that has fractions, think about trying that tool and see if it makes it easier for you to do. Okay? As I discussed yesterday in class, the assignment today is a worksheet with 11 problems. Some of them are going to be super easy. Some of them aren't. There is an answer bank. But I need to see your work, much like all of this, when you submit it, okay? So for assignment 36 today, you are going to solve multi-step equation puzzle time. It's in Canvas only. Show your work on paper. So write number 1, write the equation. It's x plus 36 equals 4x. That's the first one. That one should be a pretty easy one to do. So this is reviewing everything from yesterday and today. You will see some fractions in there. You'll also see some decimals. And I didn't talk about clearing the decimals, but just like we clear the fractions, if you don't want to work with decimals, you can clear a decimal. And how do you clear a decimal? Well, you multiply by 10, or multiply by 100, or multiply by 1,000, whatever value you need to get you there. Okay? When you submit this assignment, you've got to submit these notes that you finished and the worksheet problems 1 through 11. Good job today. You can always turn back and reference this again if needed. I will see you on Wednesday for some good discussion.